a software thing called Viveport, which is kind of like Microsoft or Xbox Live, where it's like you pay a single subscription and you get unlimited things. The software is pretty janky to control it, but it's a pretty big thing of apps, and you get to try a zillion different VR games for $8 a month. Yeah, so like Walking Dead, Saints and Sinners is on there. Yeah, so you don't have to pay $50 for this game or $40 just to try it. Yeah. You could just try a zillion games, and if you hate it, you just delete it and move on. All right, am I recording? Yes, we're up on all the screens. Okay, let me get our project open. We have a traveling salesman thing. And then let me just remind ourselves. Okay, so last time we were dealing with reading stuff in from a file. How do I return two things, right? So for the homework, add the ability to our current code to get towns, for get towns to return two values, the array and the length of the array in a single variable type, right? Okay, so I mentioned last time that, you know, we could, this would probably be the type of thing that a struct was kind of built to do if this is all you needed it to do. So let me actually just go ahead and show that as an intermediate step, even though I expected you to probably create an object to do this. But so what I'm going to do up top here is I'm going to create a struct type. We're going to call this, what is my get files thing called? Am I not? Didn't I write this in here?
Yeah, it should have been in there. I don't know that.
Did it not save like what you had?
I know the link you have in Blackboard is the same that like the most updated version that we have.
Oh, interesting. Well, let's make sure I'm operating off your same start point. I probably updated my just make sure this guy does what he's supposed to do for a moment. Yep, looks like it. All right, so right now get towns is returning a array of town pointers, but we don't have a way of knowing how many towns we have. So what I would probably do, that the old school way of doing this for just solving this problem would be to create a struct, or if maybe in Python you would create a dictionary, something like that, is I would go ahead and I would create a struct, maybe called town collection, something like that. And this struct would have in it a town pointer, maybe the towns, and then an int, maybe just an int count, something like that. And then what get towns would do is it would actually return a struct town collection. I do need to define those guys in that order. Otherwise, I have to prototype my struct town collection. So it'll return one of those guys. So down here at the bottom, when I'm returning my collection of towns, let's see, so I make my initial pass where I go through and I count all the things. Then my second pass goes through and fills up the array with my things. So inside of this else, I'm no longer returning just my collection of towns. I'm going to create a struct town collection called TC. I'll say TC dot the towns is equal to collection of towns, TC dot count is equal to count. Return TC. All right, so when I was ready to return, I created a struct. Now I'm not creating an instance of structs. If you remember correctly, I had mentioned that sometime long time ago, that structs by default are passed by value, whereas objects are passed by reference. In this case, I am literally returning a value that is called TC. It's a struct town collection that holds two values, an int and a array of towns. I could have it return a pointer if I really wanted to, but there's no reason to create new memory for my struct and then only to have to delete it later on. So now up here, I'll create my struct town collection. I'll call it TC up here as well. Actually, we'll call it TC. And then what I'll do is I'll now have a for loop for int I is equal to 0. I is less than TC dot count I plus plus TC dot the towns at bucket I display. I do have a display inside of town, don't I? Yep. So there's all of my towns. I'm still printing out some stuff down here. Get rid of that. Only place I'm printing. Oh, line 82 says it reaches it doesn't believe that oh, actually it's a main. No. It wants me to have a return statement as part of this town collection thing. So because I've promised I'm going to return something, and we know that we will eventually get into this else. We know that's a true story. It's a true story. So we are returning inside here, but C++ isn't necessarily convinced that we've returned something. Java would not let us get away with this. We would have to go down here and do something like a return null or something. What is it? Do something like that. Does it not like me using? Oh, it can't convert a 0 to a town collection. I would have to create like an empty town collection or something like that. And then I could return it. Or I could actually create my town collection before the loop in preparation to fill it. I can then fill it inside here and then return it down here. So the second pass through my for loop, I go ahead and fill up my struct with my two values, my collection of towns and my count. Then I let the for loop die a natural death. It'll finish that last pass through. And then I'll return TC, which has been filled up. So now he shouldn't complain anymore. All right, and I'm printing out a 7 somewhere. Oh, it's because my cities has that 7 in it. This is my old version. I only copied back over the syntax from the wrong thing. Let me make sure I save here just so I have it. All right, so there's all of my files or all my city names. So I'd probably, so let's say that's a solution to the homework. Probably not the solution that you did, but hopefully you actually see that for this specific thing we're trying to do, structs are actually pretty convenient, right? It's like, hey, I need to hold 2 things. I'll invent my own data type real quick, call it town collection, and boom, I have 2 things. All right. The alternative, which is probably what I think I said at the end of class, maybe we do it as an object because that's a much more modern way of thinking about it, especially since our more modern languages have kind of done away with structs. They have this concept that, oh, well, isn't a struct actually a class that only has fields in it? So I actually could have defined it up here. I could say something like class town collection. And then I can have a public section here like that. And then down here, when I first create my town collection, I'll create a empty town collection. I should have a no argument constructor that gets created for me, even though I didn't write one. We'll see in a second. But remember that when I use the new keyword, this gives you a memory address. So objects by default are passed by reference. So I'm no longer holding a town collection, I'm holding a town collection pointer. So this guy's no longer returning a struct, he's returning a town collection pointer. Town collection pointer. All right, but all my classes is my 2 fields. And then in here, I'm receiving a town collection pointer, which means I don't access TC like that. I access TC, well, TC's count like that with the arrow, because it's a pointer. I need to say TC, resolve yourself to your value, then give me the count. So similarly down here, I have my town collection pointer TC. When I actually go to fill it up with stuff, I'll set the towns equal to that, set the towns equal to that. I'll return TC, or set the count equal to that. I'll return TC, which is my town collection pointer, which is what this guy now returns. Oh, I still have a dot up there when I print it. My arrow. And there's the same output. So now you certainly could have put this in its own file, right? File called town collection. You could have done a town collection HPP and then have a town collection CPP, which includes that. And then maybe write a no argument constructor that does nothing. You could have done all that. But hopefully you're seeing, at least by our example here, that, and actually I'm going to duplicate it just so you can see the difference here. This is a struct. Call that guy a town collection struct. Procedural programming language. And then when we introduced object-oriented languages, we gain the ability to do this. These guys look pretty similar, don't they? So hopefully that kind of defends. In an earlier class when we talked about probably in 250, I probably mentioned it in 200 as well, that effectively the difference between a procedural language and an object-oriented language, when I first lecture on that, I talk about it like from the perspective of a telephone. The procedural telephone's your pile of wires. The object-oriented telephone looks like a telephone. Well, so I sometimes will reference that. What does an object-oriented language really do? It gives us a piece of Tupperware. It gives us an organizational unit that allows us to stuff all those wires into something, and it potentially have some abilities. Okay, so we would say that a class is a collection of 0 or more fields, constructors, 0 or more constructors, and 0 or more methods. So the simplest class is a class with nothing in it. This right here, that's a legal class. You don't have to have any members in your class. Yeah, well, somebody might wonder, why did you make a class, right? you go to Home Depot and got an empty box, but the box was very structurally unsound, so you couldn't even use the box. Something like that. This is legal. All right, but I'm choosing to use the class thing here to hold 2 fields, but nothing else. I didn't give it any abilities, anything like that. So a lot of our more modern languages say, oh, well, let's get rid of structs, because you can basically build a struct with a class with no constructors and no methods. Well, you could build it with constructors, so you can conveniently set these guys up. So I could have also come in here and created my town collection constructor and had this guy take in a town pointer the towns and an int count, and inside here set this the towns equal to the towns, this count equal to count. And then when I go to build my town collection, so I have scope on this guy. I need to define him outside the for loop since I'm going to return him after the for loop. But what I would do is I would say TC is equal to a new town collection, passing it the towns and passing it count. A little bit more convenient to build your struct with that constructor rather than having to define it and then put 2 lines after it to set each field. But ultimately, what did we do? We just stuffed those couple of wires inside the constructor. It's an organizational unit. Code's still there, right? I'm still directly setting the towns and directly setting the count. I just hid it away inside of that construct. The towns was not, let me make sure I'm taking in the right type for it. Okay. That looks good. It's complaining on line 90. Oh, because it's not called the towns down there. It's called collection of towns. So there's same output. All right, but kind of the lesson here would be from a computer science perspective, that even though these 2 guys seemingly are solving the same problem, they are not actually functionally identical. This guy by default is passed by value. By default is passed by address. I don't use the new keyword to create a struct. I could create a pointer for a struct, but what if I'm returning that struct from a function? So let's assume that I had my function down here returning my, what did I call it? My town collection struct. So I created a town collection struct. Then I return a pointer to that guy. What happens at the end of my get towns function? My struct that I built would get reclaimed. So that would be a pointer that points nowhere. Does that make sense? So if I built a struct in here and then I return that struct, I get a copy of it. So it persists because the local copy of that inside of get towns will die. But if I pass out the address to where you can find that struct, it's going to be gone. You follow that address, that house has been destroyed. All right, because the scope of the struct lived only inside of get towns. So if I did return a struct, I'll just pretend to do it here. If I say struct town collection struct, and let's assume that I TCS, and let's assume I filled it up with stuff. If I return that, I'm good, because structs by default are passed by value, and value means give it a copy. All right, doesn't matter what happens to this local guy, you're getting a copy of it, go do your thing. But if I said, hey, you know what? I like passing pointers because structs might be too heavy. And I say, I'm going to go ahead and return the address of that struct. Everything will look legit until you try to access that struct outside of here. Why? Because the struct I created in here, this guy's memory will get reclaimed at the end of get towns, which means it's no longer accessible. So my external thing, now that I passed it by address, won't get to anything. So how could I create a struct that would, how could I return the address of a struct or a pointer to a struct? Because I'll probably change the syntax slightly. How could I return that guy and have it be an address? How would I have to change the way I created my town collection or my variable TC? Well, it's going to start off being a town collection struct, right? Like that, but it's going to be a pointer. I want to hold the memory address of one of these guys. But how do I do that? How do I create a struct of the correct size and memory? How much memory does a town collection struct take up? Let's start with this question. Oh, go ahead. Okay. Well, but what's in a town collection struct? I'm asking, how big is this guy? If you're storing that guy in memory somewhere, what's his footprint? How much does he weigh? How much memory do we need to hold that variable? What kind of animal will the towns hold? It's representative of an array of town pointers, right? But what's the actual value? If I were to print out the towns, what's the actual value I would get out of that? If I came up here and instead of getting the value at each of those, I just did a C out on the towns. What would this display to the screen? And actually, let's start with this. What would that display to the screen? Go ahead. Yeah, memory address, right? So the memory address to wherever in memory, wherever else in memory, was the beginning of that array. And it would do that TC count number of times. in this case. So I get the same memory address a bunch of times. What would this print out? Remember, and I'm kind of blurring the line here between our classes and structs. So you can just assume we're working with a struct right now, but the answer is going to be the same regardless. The towns at a certain position, the towns at bucket 3 is what kind of animal? The towns is a town pointer. So the towns at bucket 3 is a pointer, which is the address of a particular instance of a town. So this guy will print out a whole bunch of different memory addresses, but still memory addresses. It'll print out the memory address where the first town lives. It'll print out the memory address where the second town lives, and the third town lives, the fourth town lives. That makes sense? But those guys are strewn all about memory, presumably. Every single time we built an instance of a town, we asked our new keyword, hey, give me a chunk of memory big enough to hold a town. And it came back with the address saying this is where you can go build that dude. Make sense? All right, so back to my question. How big, how much memory do we need to store a single town collection struct? And you can try to answer it exactly if you want, or you can just give me the generic answer to this. Well, how many pieces of information am I storing? 2, right? How big's the first piece of information? How big is that? Remember, we just talked about it, that the towns is a single memory address that happens to point somewhere else in memory where we have a collection of memory addresses, right? But the towns itself, the value of the towns is a single memory address. So how much space do we need to store the variable, the towns? I said you can answer generically if you want. However big a memory address is, whatever that is. You know, I think I mentioned that maybe in a, if you're in a 64-bit operating system, maybe the memory address is 64 bits. Yeah, Linux, actually, modern Linux does it as a 48-bit address because they have 16-bit addresses that are reserved for like the super user. But bottom line is, how much space do we need to store one of those guys? However big a memory address is. That's the amount of space. Okay. How much space do we need to store this guy? Generically, however big an int is, right? Most languages, an int is 32 bits. All right. So if we assume that this guy is 64 bits and we assume that this guy is 32 bits, we have 96 bits of information is how much space we need for this struct, right? Now, we've seen it before, but there's a function built into C++ called size of. We could just say, look, how much does this guy weigh? So we could just pass him a struct and say, I need that much memory. So we could have down in here, we could do something like town collection struct pointer TCS is equal to town collection struct pointer of malloc size of a town collection struct. Allocate some memory for me. How much memory? Big enough to hold one of these dudes. Whatever that is. We don't have to, I mean, we just went through the exercise of thinking through that, right? Okay, presuming there's no overhead for the type name or something like that, and there's typically not, but we don't have to worry about, in order to use it, we don't have to have the knowledge of how was the struct actually built and stored in memory. I've just kind of revealed that a little bit for us, but we can ask the C++, which then asks the operating system, like, look, how big is this guy? And it says, oh, let's assume our math was right. It's 96 bits. Great. Give me that much memory and go ahead and convert it to a town collection struct pointer for me. That way I kind of have the right guy. So when I start saying things like TCS, arrow, the towns, it kind of knows what I'm talking about. It's treating it as a pointer to a town collection struct, not as some generic void pointer. All right, so we could build a struct by asking for our own memory that will not get reclaimed at the end of our function, and then return that pointer, and we would still have access to it outside of this. Same exact thing we dealt with when we looked at arrays, right? This isn't like some new information. This is, did I make the memory, or did I rely on the operating system to generate this memory for me? Understand that distinction? I might make the argument that, hey, just always rely on you making the memory, cleaning up your own mess, but then you know that anything you're passing by address will still be there. But since structs are passed by value by default, we didn't even have to ask for memory. We're just saying, hey, make me a struct, fill it up with whatever I want to fill it up with, return a copy of that struct. But we do need to be careful. That is to say, if my collection of towns was built using kind of our built-in way that we can build arrays, just kind of putting the brackets here and say, okay, I'm going to hold 15 of those. Now we no longer control that memory. So even though our struct is passed by value and it survived, one of its components, when the struct gets its towns outside of here, when I try to get this variable from that guy, it's going to have a null pointer because the memory that he was built with is gone. That's why when we built our collection of towns, we asked for some memory. We are now responsible for that guy. Make sense? Which also then means if I'm being a good steward of memory here, I should come down here, and when my code is done, I should say delete TC. Clean up that memory. I allocated it someplace else. I returned a pointer to it here. I'm done using it. Give it back to the operating system. That makes sense? How we're kind of juggling memory here, but if we're connecting this to real life, if you make a mess, your job is to eventually clean up that mess. Even though modern operating systems will do this for you. We saw it run. It didn't do any screaming or anything like that, right? But following through here, this is what we would want it to do for us. All right. So you can pick your poison, what you want to use here. I'll leave the town collection struct guy in here. I'm deleting my instance of my class here, which is fine. Inside here, I'll go ahead and just comment this out so you can kind of see how do we allocate enough memory for a struct, but it's no different than anything else. If I want memory for an int, malloc size of int. If I want memory for a certain class, malloc size of whatever that class is, so on and so forth. Then I went through here. I built my collection of towns. This is where I'm asking the operating system for memory. Then I'm ultimately returning my struct or my instance of my class. Town collection right here. This is where I'm asking for memory for that guy. I'm returning that guy. And then I am, well, I'm building him here. I'm getting new memory here. I'm returning him here. So I made my mess right here. Secondarily, I made an extra mess here that this guy was built in terms of. So I actually have two messes. So up here, when I catch the result from get towns inside of TC, this guy is a town collection pointer, then I go ahead and use this guy. If I really wanted to be thorough, I should first delete TC the towns. Clean up the first mess I made. Then go ahead and clean up the second mess I made. But like I said, this will get done for you, but if I'm being really explicit here, clean up your own mess. Oh, I'm currently printing out there's your example. Those are different addresses for our different towns. We had mentioned that what will this code do? It will print out the address of each individual town. So we notice that the towns live throughout memory, even though the array that is the towns is stored in contiguous memory. Bucket 0 of it is a memory address. Bucket 1 of it is another memory address. Bucket 2 of it is another memory address. But those memory addresses are not necessarily next to each other, because I built this town, then I built this town, then I built this town, so on and so forth. So really what I want to do here to get us back to where we were is I want to call the display method on an individual town to give me the names of my towns. All right. So we're being a little bit anal here probably by really diving into this delete thing, but I want to drive the point home with memory that if you make the mess, it's your job to clean it up. And I'm cleaning up my first mess, and then I'm cleaning up, you know, it's kind of like I dumped a mess into the garbage can. Then I created the garbage can. I created the garbage can. I dumped it. I created a mess. I created a garbage can. I dumped my created mess into the garbage can, ready to take the garbage out. Garbage man comes by. What does he need to do? Well, he's going to get rid of the mess, and then he's going to destroy the garbage can. Something along those lines. All right, so questions about any of this stuff. So a couple different approaches to what you could have done for the homework, but my expectation would have been something like that. Whether you put it in this same file, since you know we're just using it as a convenience thing here, or you put it someplace else. Okay. Make sure I save this. All right. One way or another, now we have our list of towns read inside of this variable type town collection, so we can get at each of those towns. Now, these are the town names, right? So what comes next? So what we've done so far is we've covered this part of the equation, right? By having this file with all my town names in it, I've solved the problem of, oh, I can create all these towns. Done. I have my town collection. But now I need to create these roads. So maybe we go ahead and we have another file, roads txt. Okay. Now what's going to be inside of roads txt? Now you are going to need to make sure that you do something like that with it. Now you can put this format however you want, probably to make this easiest for us. Let me just do this real quick. Just want to make sure I give you enough stuff to not focus the homework too much on things that'll take you too much time. access to a string. Upgrade class, road parts is going to have a public section, and the parts of a road are town name. So town 1 name, town 2 name, and distance. String town 1 name, string town 2 name, and int distance, like that. All right. So that's my road parts. Now I'm going to go ahead and I'm going to have a new function here that's going to return a road parts pointer. And we're going to call this guy get roads for right now. But I'm actually going to have him only, let's see, actually, let's call, I'll call this guy parse road for right now. And he'll take in a string road string as a parameter. And the way that I'm going to actually call this guy is I'm going to say road parts pointer RP is equal to parse road. And I'm going to pass him a string that looks like that. A string that you may have just read in from your file. Okay. And then the idea here being that you should be able to do a cout. Actually, we can go ahead and do it inside of, we can have a void display and have this guy do a cout. Town 1 name, space, town 2 name, space, distance, and L. And then we'll go ahead and have our constructor. So road parts. We'll take in a string. I'll just copy it from here for time. Town name 1, a string. Town name 2, an int. Distance. And we'll set town name 1 equal to town name. This town 2 name equal to town 2 name. This distance equal to distance. So that's what that constructor will do. So if I were to pass this guy in that information, returns an instance of road parts that has the string, well, that has road string parsed into pieces. For example, that guy should break into a town one name of Belgium. Town two name of Fredonia. And distance of 6 as an int. And return that object. That makes sense what this guy does? He takes a single string as a parameter somehow, and that string looks like this guy, and somehow breaks it into his 3 pieces, building an instance of a road part and returning it. Okay, so your homework, write that guy. You're not reading in the whole file, you're just writing that one thing that takes a single string in, splits it into its 3 pieces, and returns an instance of an object with that stuff. Questions, comments, concerns, bribes? All right, I'll save this. I'll put up the link to this guy with the code, and I will see everybody on Monday.